Hey there, Math 126 fans. Going to talk about graphs and labeling. As we go into chapter 15, we suddenly need to graph a lot of regions. It's a lot about working with regions. I feel like it just builds on those 125 skills, but if you're fuzzy on your 125 or it's been a year since you've taken it, sometimes students tell me they have apprehension about these things. So I went through and looked at the homework, and this is everything that you have to graph in your homework in 15.1. Now, you are expected to know your standard graphs, so sometimes students go, well, is there something out on this list? So I made a previous video, watch that previous one, where I talk about graphs you definitely should know. But these shouldn't scare us. Circle, square root, square, 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 line, half circle, square, line. There's an inverse sign, but really you just have to know how to graph sign. Cube root, line. That's all you're really seeing in the homework. So if those are scaring you, then I feel like the issue often has to do with labeling. And so I want to talk about that. It's a big topic I talk about in Math 125. It's very important. I would say at least it's more important than anything else we're doing. So if you don't know this, it's worth just stopping and learning it. So usually I start with as simple example as I can. I take a line. And I find that there's some sort of disconnect, and so I want this. If this isn't you, that's fine. But if I hand a student a number, if I say, okay, I'm going to give you x equals 2, you tell me what y is. Most students will get that right. They'll plug it in and they'll say y is 7. And then I might say, can you label that in the picture? And I feel like I always lose some people there. And that's an important thing that somehow has gotten missed along the way. The connection, the geometric connection. Okay, so let's label what this means. X equals 2. We've all agreed, it doesn't have to be this way, but in the Cartesian coordinate system, that to the right on the x-axis is positive. It means 2 units this way. We often label with a tick mark, and that's where we put our x. When we graph, then this is the y. I know it's kind of basic, but this is where I see a lot of mistakes. Okay, so that's what that means. Now, what we'd like to be able to do is actually label it, like an architect. So let's label it and say, if this is x, what is this? I know I'm kind of going basically, but this is, as I said, where I see the mistakes. This is 2x plus 3. And over the years, I've noticed, I'll be talking to students, and I realize they don't know that piece. They know that if they plug in a 2, they get a 7. But they don't know that if they plug in an x, they get a 2x plus 3. And that's a big stumbling block. If you don't know that, it really messes things up. That's how we label it in terms of x. Now, we could just as easily label it in terms of y. And if you're going to do calculus, you need the flexibility to be able to label it either way. So same picture, same line. I'm trying to keep that stuff as simple as possible. And this is one of the biggest stumbling blocks I notice in Calculus 2, and it lingers into Calculus 3. And as I said, it's probably more important than anything else we're doing in this course. The ability to just work with graphs. Okay, so the other way we could do a problem is we could label it in terms of y. We could say, well, someone's going to hand me a number y. It's the same sort of thing. If someone just gives me the number, we could go in reverse. They hand me the number 7. A lot of students would do it right. They'd put a 7 here and they would solve. They would subtract the 3, so they would make this a 4. They would divide by 2, and they would get 2. So what did we do? Can we shorten that up? Can we find a formula for it? We definitely would like a formula for it if we would like to label this length, which we often want to label. So sometimes we don't realize this. The moment someone hands us this formula, we should be also thinking about its inverse, meaning subtract 3, divide everything by 2, and you get x equals y minus 3 over 2. That comes for free. That goes with this function. We get both. And that's what this length is. And you can always test it out. If I plug in a 7, do I get a 2? So in your mind, when you are working with graphs, it's very important to understand that there's 2 starting places, at least for now. You could label it in terms of x or label it in terms of y. To really make this explicit, I tell students, if you're doing a geometric problem and you're finding a pattern, your first step will be to either label x or label y, and then label everything else in terms of that. Often you'll be thinking about both and trying to decide which one leads to simpler formulas. Okay, so we'll talk a lot about that in class, but we have to have that starting place. So I just picked a random other example here. So if I have this function, currently it's stated in terms of y in a nice way. So when I look at this, I go, my first step here would be to think of it in terms of y. Y always means how far this way. And I know they told me this is y squared plus 1. So it's already written nicely in terms of y. If I wanted to do it in terms of x, then I would need to rearrange. X minus 1 is y squared, and this leads to two possibilities. Y equals negative the square root of x minus 1, or y equals the square root of x minus 1. And that's notable in many problems because that often means we have to split up our work. But the thinking is the same. So label this x based off of x. How high do I want to go? Well, there's two possibilities. I could do the square root of x minus 1, which is this upper part of it. Or I could go to negative the square root of x minus 1, which is the bottom part of it. And oftentimes that's something we have to understand. Hey, if we do it in terms of y, there's just one pattern we have to know. If we do it in terms of x, there's two. Okay, so I just wanted to say about the labeling, because that's usually where the sticking point is. That's often where the confusion lingers. And so I feel like a huge thing you can always do is draw two pictures if you're really stuck. For one of them, put x as the starting place. For the other one, put y, and label it both ways. Okay, that's a big part of what we're going to be doing. So when I see these problems, someone hands me a homework question and says, draw the region bounded by whatever. This is a homework question. I first know the general shape. I know that that's a line. If you don't know if it's a horizontal or vertical line, don't guess. Just plot a bunch of points where x is 4. That's what you should do. So x is 4 right here. Plot a bunch of points. They're all going to be here. That's what x equals 4 means. It's a vertical line. Then I'm going to draw x equals y squared. Like I said, some people don't know that graph. They get worried about it, but it's this parabola. But if you were unsure, you could think of it both ways. You could write x equals y squared, or there's two possibilities the other way. This or this. That already suggests that maybe it will be easier to use y. So in my head, I'm thinking of two possible pictures. So let's move over and just think about that. So if you have this plan, I think that the problem is often people are just guessing, or they think they have to have. There's an unfamiliarity. At any point, you could plot numbers. You could make a table of values. But it really would be nice if we didn't have to always do that. But you could make a table of values, 0 and 1 and 2, and compute what the x is, and plot them. That's the way to do it. But this is faster. So in terms of y, when I plug in a 0, I get a 0. Oh yeah, it's this parabola. So when I look at this picture, I feel like I would like to start on the y-axis and start walking because I know the pattern to get to there, and I also know the pattern to get to here. And it's the same pattern no matter where I go. If I was here, it's going to be from there to there. If I was here, I would have been from there to there. So I like that. Okay, if I did it in terms of x, then I have these two possibilities. I have the upper root, and I know now I'm labeling it in terms of x. This point right here is all the way up at the square root of x. And then separate from that, I would have this one. negative the square root of x. Well, I kind of like the first one better. Maybe the second one's fine too in this case. That's the thinking we're doing. So I just wanted to say that because I find that some people, the issue is the labeling. If that is your issue, I would be happy to work with you. I have many videos on that I did for Math 125, and I can link you to those. We need to be able to label our picture in terms of X or in terms of Y, because then we can make informed decisions about which way would be better. All right, hope that helps.